If someone were to say that Tesla is redesigning not just a car, but the very concept of how a vehicle is assembled, it would probably seem like an exaggeration. But that's exactly what's happening with the Model 2. For the first time, a city car is getting a structure inspired by the world's most advanced race cars. What was once exclusive to the tracks of Le Mans is now being shaped to run on the streets of cities like New York, Paris, and São Paulo. And the key part of this change goes by a name that still sounds futuristic to many: Giga Casting. Instead of assembling the body with dozens of welded parts, as has always been done, Tesla is using massive single blocks of cast aluminum to compose entire parts of the car. This isn't just a time-saving production trick, it's a complete transformation in engineering. The new chassis places the wheels almost at the ends of the vehicle, an unusual configuration that completely changes the game. This drastically reduces the so-called overhang, the space between the wheels and the nose of the car, and requires meticulously planned engineering to absorb impacts and support all the vehicle's vital systems. With this reduction in free space, old support structures like subframes, cradles, and suspension struts simply no longer fit. They need to be replaced with something more compact and efficient. This is where the extreme use of Giga Casting comes in. The suspension, engine, and entire drivetrain are literally integrated into the car's structural block. This eliminates welds, fittings, and components that, in addition to being heavy, were weak points in collisions and required constant maintenance. The Model 2 is not only lighter, it's simpler, and at the same time, more robust. This type of integration was already being tested on the Cybertruck, but what's impressive here is the scale. While the Cybertruck is a conceptual and experimental vehicle, the Model 2 was designed to be mass-produced and driven by millions of people around the world. It's as if Tesla decided to take the technology of a supercar and put it in an entry-level city car. Sound crazy? Perhaps, but it's precisely this kind of boldness that is allowing them to cut costs and accelerate production without compromising safety or performance. The result of this new architecture is a car that's stiffer, lighter, and has fewer moving parts, which means less noise, less wear, and fewer problems in the long run. But it's also a clear sign that Tesla doesn't just want to make more cars. It wants to make cars in a completely new way. The efficiency gains are so great that assembly lines require fewer robots, fewer processes, and less energy to assemble each unit. This paves the way for large-scale production that was previously unimaginable for a car of this size. And it's this same logic of intelligent simplification that's beginning to appear in other areas of the Model 2, such as the roof. After fusing the main structures into a single block, Tesla now appears to be applying the same modular principle to the upper part of the car, with a proposal that could transform the way people choose, upgrade, and customize their vehicles. If you look closely at the leaked images of the Model 2 prototype, you'll notice something strange about the roofline, especially at the rear. Unlike current Tesla models, where the roofline follows a continuous, smooth curve, this new model breaks that line just after the C-pillar, creating an unexpected angle. To many, this may seem like a mere aesthetic choice, but for those who understand automotive design, this detail is a telltale clue. The break in the curve indicates that the rear roof isn't a continuous piece with the bodywork. It's most likely a separate module, designed for easy removal or replacement. This modular roof idea isn't exactly new in theory, but no one had been able to apply it on a commercial scale until now. What Tesla is testing here is the possibility of offering multiple roof versions for the same car. And we're not just talking about aesthetics. A basic metal roof, for example, can reduce production costs and make the model more affordable. A glass roof, in addition to giving a more sophisticated appearance, increases the car's perceived value. And the most daring, a roof with integrated solar panels capable of generating extra power for the electrical system, something that, until now, seemed exclusive to concept vehicles. Interestingly, All these roofs would be interchangeable. With a quick-release system made up of mechanical pins and a simple connection cable, any version could be swapped in a workshop or even during assembly on the production line. The structure is so practical that the process would take less than 15 minutes, according to estimates. This speed is not only an advantage for production, but also for after-sales. Imagine buying a Model 2 with a metal roof, and, months later, deciding to invest in a sunroof. With this system, the swap would be simple, quick, and without the need for body modifications. Another interesting detail is that this type of modularity also affects the car's aerodynamic performance. The most basic version, without a spoiler, will have a higher drag coefficient, which means lower fuel efficiency. The version with a glass or solar roof can include an aerodynamic spoiler that fits directly into this upper module, reducing drag and improving the car's range on a single charge. This allows Tesla to deliver a cheaper base model and, at the same time, a more efficient and profitable premium version, all from the same chassis. This strategy has profound implications. With a single body style, the company can serve different audiences and different markets with distinct needs. In countries with warmer climates, a white, thermally insulated roof may be the most sought after. In colder urban markets, a glass roof may be preferred for its visual comfort and style. In places where electricity is expensive or scarce, a sunroof can become a real differentiator. All this without changing the car's basic structure, without creating different versions in the factory, and without complicating future maintenance. And it's not just the roof that follows this modular logic. A closer look at the rear of the car reveals another clue: the vertical cuts in the rear panels. They're no accident. They're further evidence that Tesla wants to transform not only car production, but also the way it's repaired. And what comes next promises to mess with the minds of anyone who's ever taken a dented car in for repairs and left with a heavy wallet. Can you imagine a car that, after a minor crash, wouldn't require weeks in the shop or cost anyone money? Well, that's exactly what the vertical lines on the Model 2's rear end suggest. Unlike previous Tesla models, where the rear end was composed of large, single-welded pieces, this new approach divides the rear end into independent modules. This means that instead of replacing or repairing the entire rear end after a collision, simply swapping out the damaged module is enough. And it can be done in less than 15 minutes, with simple tools and without the need for specialized equipment. These rear modules have been strategically divided. The lower module includes the bumper, taillights, ventilation grille, and possibly reverse sensors and even an auxiliary battery. The upper module encompasses the rear window, trunk support, spoiler, if equipped, air intakes, and rear-view camera. This separation allows each part to be manufactured, transported, and replaced independently. Furthermore, they can vary depending on the car model. A basic Model 2 doesn't need a spoiler or advanced sensors. The premium version, however, can come equipped with wide-view cameras and additional components to support full self-driving. This approach has a name: service-centric panelization. It's a design philosophy focused on easy and affordable maintenance. Until now, it had only been adopted by supercar brands like McLaren or commercial vans like the Ford e-Transit. Now, it's being applied to an affordable, mass-produced city car, and that changes everything. With this design, repair costs drop dramatically. The current average cost to repair the rear end of a Model 3 after a city crash is around $1,800. With the new modules, that cost can drop to less than $400, and that makes a huge difference for those on a tight budget. In addition to the cost, the wait time for repairs also plummets. Instead of relying on heavy bodywork, welding, and painting, the new system allows for direct replacement of the damaged part. This can be done at Tesla service centers or even by accredited repair shops, speeding up service and reducing wait times. In some cases, with pre-assembled parts, the owner can even replace simple modules at home, much like replacing a bicycle light. This type of accessibility elevates Tesla's customer relationship to a new level, making the Model 2 not only cheaper to buy, but also cheaper to maintain over the years. Now consider the impact this will have on countries where the cost of repairing electric cars is still a problem. In Brazil, for example, crashing an electric car often means sitting it for weeks, waiting for imported parts and astronomical budgets. With this modular structure, this scenario changes. A minor accident stops being a nightmare and becomes a quickly manageable situation, with more accessible parts and quick replacement. This could open the market to thousands of people who still view EVs as unrealistic. Interestingly, all this attention to maintenance and modularity directly reflects another aspect of the prototype's attention: the car's paint job. Yes, even the way the body is painted reveals another bold move by Tesla. And if the roof can be replaced and the rear can be disassembled like Lego bricks, why not apply the same thinking to the painting process? The answer lies precisely in the white color seen in the leaked photos, and it's no accident. From afar, it may look like just another white car, like so many others cruising the streets. But if you look closely at the Model 2 prototype, one thing stands out: only the center section of the body is painted, while the front and rear sections remain camouflaged with fabric. And there's no dividing line between them. No decals, no visible lines, no tape or stickers. What appears to be just an assembly detail may actually reveal one of Tesla's most significant leaps in industrial efficiency so far: the use of selective partial painting in the manufacturing process. This technique, previously unheard of in mass production, consists of painting only the central structure of the car, which represents approximately 60% of the total surface, leaving the ends to be assembled later, either in their final color or even in unpainted material. This has several immediate advantages. First, painting time per vehicle drops dramatically, from approximately 42 minutes to between 24 and 26 minutes. This time savings, when applied to hundreds of thousands of cars per year, represents a colossal gain in productivity. Furthermore, it eliminates complicated steps, such as rotating the car inside the paint booth and uniform heat curing on the vehicle's ends. The technology used in this process is also noteworthy. The prototype's white paint isn't just any white. It's most likely a new type of electrochemical heat-reflective paint capable of reducing the car's interior temperature by up to 17.6 degrees Fahrenheit, almost 10 degrees C, when parked in the sun. This reduces the need for air conditioning, which is especially valuable in vehicles with smaller batteries. It's estimated that this thermal gain can increase the car's range by 5% to 7% in hot conditions. It's not just a pretty color, it's a functional choice that directly improves the user experience. Another interesting point is that, by painting only the center of the body, Tesla gains enormous freedom when adapting the car for different markets. The center section can be standardized across all factories, while the extremities, such as the front or rear bumper, can be customized according to each region's regulations. A practical example: the American version can have a wider rear bumper, while the European version, which requires different reflectors, can use an alternative rear set without changing the car's underpinnings. This allows for flexible production without additional re-engineering costs. The impact of this system goes beyond assembly. It changes the very concept of variety on the production line. Instead of building different cars for each country, Tesla can assemble a universal base and customize it in the final stages with market-specific parts. This concept, called zonal post-paint final assembly, is already being tested at Giga Berlin with the first robotaxi prototypes. And now, everything indicates that it will be fully implemented in the Model 2, a car that, despite its small size, is carrying the weight of a revolution. With this, Tesla's production capacity could literally double. The Fremont line, for example, which currently produces around 475,000 cars per year, could reach over 950,000 units per line with this optimization. Multiply that by 2 lines, including the one in Giga, Texas, and you arrive at an annual production of over 2 million vehicles. All this with a modular structure, faster to paint, easier to assemble, and with less inventory requirements for specific parts. Sounds exaggerated? Perhaps. But looking at each of these innovations side by side, it's hard to deny that Tesla is laying, piece by piece, the foundation for the most scalable electric car ever designed. And all this efficiency only makes sense when combined with a design designed for the real world. After all, there's no point in a car being cheap and quick to assemble if it's not practical for city driving, parking in tight spaces, or navigating urban traffic. And that's exactly where the Model 2 completes the cycle. With proportions designed for everyday use, it promises to bring all this bold technology to the heart of major cities. It all starts with size. The Model 2 was clearly designed to fit where other electric cars simply can't. Its dimensions fit into the A+ and B hatchback segments, meaning it's a compact, agile vehicle perfect for urban use. But it's not just about being small, it's about being smart. The shortened wheelbase and reduced distance between the axle and the corners make the car capable of cornering with a radius of less than 5 meters. That's about what you'd expect from a European subcompact car, not a cutting-edge EV. Tesla seems to be aiming squarely at cities like Paris, Tokyo, São Paulo, and New York, places where every inch matters when parking or maneuvering. An electric car, in itself, is already advantageous in these environments due to its zero emissions and fuel economy in daily use. But the Model 2 goes further. It not only adapts to the urban environment, but is tailored for it, from the chassis to the modular details. This includes, for example, the bumpers designed to absorb light urban impacts and be easily replaced, as we've already seen with the rear quarter panels. Another interesting point is that this global urban vehicle proposal isn't limited by size. The modularity, which we mentioned earlier in the roof and rear, also serves as a kind of industrial passport. This means Tesla can adjust the Model 2 for different markets without reinventing the platform. In Europe, the model can come with a headlight assembly, adapted to local regulations and specific sensors for bike and pedestrian paths. In India, the car can be optimized with reinforced GPS antennas and more aggressive battery cooling to withstand extreme heat. And in the US, versions with reinforced bumpers and extended range are available for those who need to travel further. This kind of versatility is what makes the Model 2 a truly global platform. It's not just a cheap or small car. It's a vehicle that can be mass-produced and adapted in minutes to meet the legal, cultural, and practical requirements of different countries. This reduces logistical costs, shortens delivery times, and speeds up homologation in regions with complex regulations. And most interestingly, all this without losing the car's visual or technological identity. Unlike other automakers that create simplified versions for emerging markets, Tesla offers a single car, but one that transforms on the outside without altering its core.